So we are back at it, and I'm here making a video for my kids, my team that has missed the session, and Chester, Durang, and Samuelson, and Esther, and the rest. So, and here I'm going to be finishing up the differential equations that we're supposed to be doing, and I'm going to be explaining this paper to you. Whoever else can see and benefit, no problem. But this is going to be for specifically for my team. I'm helping you. So here we want to complete our differential equation stuff, and here we are doing some more questions, and let's see how it goes. So here I'm going to be explaining some of the things that I need you to be very good at. And what I will need you to do is that to remember that no two questions are going to be the same. So I don't want you to get stuck on parts where we are resolving a particular problem. No, I don't want you to get stuck on that. What I want you to put in your head, what I want you to recall is the part that is going to have concepts of differential equations, okay? The part that has concepts. And when we are resolving, looking for an answer, we may do some tricks that would fit a particular problem. And it's good to know them because you may use them in a different one, but you remember that problems are different depending on the topic. But anyway, let's start this one. So here's our differential equation question. Remember, differential equation is a part of integration. But now we are doing a question that is going to involve us making a differential equation. Then we are going to use it later. So let's see. Here they've given us a cylinder, blah, blah, blah. They've given us h. They've given us this is the radius. Obviously, anyone can see that. So I can know that my radius is 4 meters. Then my height is just h. Okay, fine. No problem. So now let me just say this. Whatever shape you're going to get, make sure you put the formula for whatever that is going to be related to that guy. If this is a cylinder, for example, I know that straight away, just by saying a cylinder, I'm going to put the formula for volume of a cylinder. And this is going to be pi r squared h. Okay, volumes are easy. Volumes of all shapes are easy. When you want to find volume, you look for we say the cross section. Cross section means what plane shape can you see? Plane shapes are the circle, triangle, square, rectangle, those type of things. Here we can see that there is a circle. This is the cross section. It's a circle. And we'll find area of that cross section. Then we'll multiply by the height of them. That will give us the volume. So area of a circle is pi r squared. We multiply by the height, which is h. Especially when we're looking at water. We are looking at the water. So here it's in here. The cross section is also a circle. So the area is going to be pi r squared. Then we multiply by the height, which is h. And that gives us the volume. So, okay, the moment I see a cylinder, I'm going to put volume of that thing. And here specifically for the water. Now I have, and we know that this 4 is just this r is a 4, so it's like pi times 4 squared times h. This is going to be, so it is equal to pi is this is going to be 16 pi h. This is going to be the volume, okay? Because 4 squared is 16 by pi, it's 16 pi times. So this is what we have. Now, okay, so I just put the volume. These are something to know. These are some tips to have, okay? I see a cylinder, I'm just going to put the volume because I never know when I'm going to use it. And now let's get to this. Let's see what the question wants anyway. Remember, the question is not this whole passage. That's not the question. That's not the question. The question is a small part. For this part, we'll just skim. We're going to skim through this part to look for data that we need, if there is any data we need. So here, they said show that dh dt is equal to negative lambda root h. Okay, so they want dh dt. When a question says to you show, you are not going to look at their answer right now. If it says show that dh dt is equal to something, you have to find dh dt. Ignore their answer. You find your own dh dt. And if you're correct, your answer should be the same as theirs. That's how you show. Find your own answer. Then compare. So here's the thing. We are supposed to find dh dt. And they say lambda is just representing a positive constant. Okay, let's try to find dh dt. What do we have? I have volume. Okay, if I have volume here, what is it in terms of? It is 16 pi h, right? I know that this is 16 pi h already. That's my volume. So what can I get from this? From this one, I can get dv dh, okay? Remember, you can see this h. That's what is on the other side. If I say y is equal to something x blah blah, you get dy dx. It means the rate of change of y with respect to x. Here it is the rate of change of v with respect to h, because h is the one on the other side. So I can find dv dh, but I want dh dt. Okay, it is going to be dv dh. Who else should I have? So I'm going to have to flip this, and I'm going to say it should be dh dv, and we'll see how we can take dv dh and change to dh dv. Then this should then multiply dv dt, because I want dt in the bottom. So this dv will cancel with this dv and bring it. So I need dv dt and I need dh dv. Anyway, let's go ahead. That's how I'm going to get my dh dt. Let's find what they're going to tell me here. They said that there is a tap at the bottom of the tank. Fine. There is a tap at the bottom of the tank. What is it? When the tap is open, water flows out of the tank. Water flows out of the tank at a rate proportional to the square root of volume. Square root of volume means square root of V. And we just found our volume here. Okay, so what are they telling me? Let's quickly put it. So first I'm going to say, okay, I'm calculating here. I see that this is a cylinder. So the first thing I'm going to put is the volume. Volume is pi r squared h. You can say, but r is equal to 4. So you're going to have your V being equal to pi 4 squared h, which is going to be pi by 16 by h, which is going to be 16 pi h. What is this? This is the V. Okay, this is the V. Now, what do we have? We have been told that the rate at which water flows out of the tank. This is the flow rate. Flow rate, the rate at which water is flowing out. What is that? What is changing as water flows out is the volume of the water. The volume of the water changes, okay? And the height changes. But here, the rate of flow is the rate of change in volume. So this is the one that is proportional to the square root. Remember that rate of flow is the rate of change in volume. So this is we are going to say that dv dt, the rate of change is with respect to t. Rate of change of volume, dv dt. Rate of change of x, dx dt. Rate of change of y, dy dt. So rate of change of volume, because water is flowing out, is going to be equal to, or is proportional to, rather. Since it's flowing out, it is proportional to a negative value, because what is flowing out should be proportional to a negative. And what is it? The square root of v. So negative square root of v, which is equal to, you can say dv dt. When we want to remove this proportional to sign and put an equal sign, I multiply the right by a k, a constant. So I can put an equal sign. I have removed this proportional to sign. Then I'll put negative k, then delta v. I've introduced a constant. Now, what is my dv dt going to be equal to? It is going to be equal to negative k square root of v. And we just got v here. V, we just get it the moment we see this question. So 16 pi h. There we have it. Now, what am I going to do? I'm going to say we have that V is pi r squared h. What can we get? dv dh. Okay? Even if you can't get to the final answer, get part marks for doing this. What is it? We are with respect to h. So the rest is a bunch of constants. So pi r squared will come back as pi r squared. The derivative of h is 1. So this is going to be our dv dh. It's pi r squared. No. Now, what do I want? I want dh dt. So you're going to write now to say dh dt. Okay, so now we want dh dt. What would it be? We need to have two things. Okay, I have dv dt and I have dv dh. So what am I going to do? To get dh dt is going to be dv dt, yes, times what? Now I need dv in the denominator to cancel this other dv, and I need a dh at the top. But guess who I have? I have dv dh. So I actually need to, for me to get dh dt, I have to say dv dt times dh dv. Okay, but do I have dh dv? No, I have dv dh. How do I get dh dv? I'll say dv dt times 1 over dv dh. Okay, that is how you get dh dv. It's 1 over dv dh. Okay, now let's put that. So this is going to be equal to, what is dv dt? dv dt is negative k by, what is this? We can simplify this. Why did I leave it in this state? Let's simplify this. Root 16, we can simplify it. Okay? We can. Let's simplify this root 16. How do we do that? Let me go back to the pen. How do we simplify root 16? Root 16 pi h. We can take the root of 16 out. It is a 4. So it's going to be negative 4k root of pi h. Okay? And so my superstar students, I don't want you to get confused on parts that are not remember, this is differential equations, and right now what we are doing is developing it. We're not solving, we're not integrating. Remember, when we solve, we integrate. Here we are developing a differential equation, which is an equation with a derivative inside it. Okay, we are developing it, and you can see that there's going to be some part where you use some chain rule time. Okay, some chain rule, and that is what we have done here. Because I can go ahead, let's just calculate. This is now calculations which we are doing. dv dt, we take it, it's negative 4k, so it's negative 4k pi, negative 4k multiplying the square root of pi h. And we can say this is going to multiply 1 over dv dh. What is dv dh? Is pi r squared, so it's going to be 1 over pi r squared. And we know what that is, pi r squared. So we can say this is actually dv dh is going to be equal to, so here we have it, negative 4k multiplying the root of pi h times 1 over pi times 4 squared. So this is going to be negative 4k square root of pi h times 1 over 16 pi. There we go. So what is this going to be? Negative 4k, then square root of pi h, square root of pi h, all divided by 16 pi, because it's multiplying 1 over 16 pi, right? And we're going to say 4 into 4, 1, 4 into 16, 4. So this is going to be negative k. It's going to be negative k, the square root of pi h, all over 4 pi. Okay, there we have it. Now, what are we going to do? We want to separate the square root of h, right? So what am I going to do here? I'm going to separate these two at the top. So, okay, let's just do it. I'm seeing that I'm running out of space. I should have written it to be small things so that they can fit in. Let me try to do it. Move this thing up. Let's try to move these things up. I'm going to move this up here. So here, this is a 4. Now, what am I going to get here? I don't want to spend too much time on this. So what is this? What is going to happen here? Look, this is now just simplifying. It's not really differential equations. It's simplifying, okay? So if you simplify, you're going to get negative k. Then here you're going to have the square root of pi by the square root of h all over 4 pi, okay? And what is going to happen is you're going to say pi, or you're going to say here, this root pi into root pi 1. Root pi into pi, that is another one, okay? Because what you must know is that pi is the same as over 4. Pi is the same as root pi times root pi, okay? So it's going to be like this. 4 root pi times root. Because if I multiply root 2 times root 2, I get a 2. So root pi times root pi is this pi. So that's what I can do. I can now say root pi into root pi 1 into root pi. They cancel. So it's going to be actually negative k over 4 root pi. Negative of k over 4 root pi. And this is multiplying root h, okay? And you're going to get it as negative pi root h, okay? And you can write somewhere where there is space if you have to say where. We don't have space, of course, to continue, but here it is where lambda is k over 4 root pi. 4 root pi. This is going to be your lambda, and you're done. This is going to be what you get. So this is going to be negative lambda This is negative lambda root h. And this is going to be it, and we are done. Okay, so here we were developing an equation, and we're now going to see how we then solve. Solving differential equations were quite good. It's all about integration. But here we have developed one. Even if you can't, you're going to use the one which they said show in the next one, and you're going to just solve whatever. Okay, goodbye.